Oh, welcome back. This is the second video on the new Deceleration readouts. If you haven't watched the first video, go ahead and watch that first, because I will only cover the changes I have done in the meantime in this second video. So with that, let us go to our engineer window. I have slightly redone the top three categories. I now have my surface information, latitude, longitude, altitudes, and the biome and slope. I have impact information, so time, latitude, longitude, altitude of that impact site, and the biome. And I have then my deceleration readouts. I have put them into two groups. Surface information, so again latitude, longitude, the terrain altitude at that position, the biome, and the slope. And I have my burn information, so burn time, the remaining altitude over that position after the burn, the delta V required, and I have the distances covered in horizontal, vertical, and total distance. So what has changed is quite obvious. I have added a bunch of readouts. They are based on the deceleration distance, which I figured out after I did the first video. If you remember, the last thing in the video I did was a suicide burn, which I started roughly half of the burn time before impact, so my impact time was half my burn time at just about, and I came down very close to the surface. Now, I said I don't think that will work in any case, but then I remembered that it's in school in physics you learn that when you decelerate from a given velocity to zero, the distance your deceleration will require is half your initial velocity over the time required to decelerate. And that allowed me to basically calculate all of these information. So I know the distance I will cover both in horizontal and vertical direction. And from that, basically from the horizontal velocity, I can calculate a point, get my initial point, get the direction, get the distance, and I have a latitude and longitude. And from that, I can get the altitude at that point. And if I combine the altitude from the position, I also get the biome and the slope. And from the altitude, if I combine it with my vertical distance, I can calculate a remaining distance, which tells me how close I will be to the surface if this falls below zero and I am on a suborbital trajectory. I'm sorry. I know I am going to have a bad day / crash landing. Without further ado, let me demonstrate just that. I am again using the same save I did in the last video, and I am going to do that suicidal last minute burn. But instead of comparing my impact time and my deceleration time, I will just look at my remaining altitude, and when that gets very close to zero, I will start my burn and hopefully come to a stop a few meters over the ground. This will just take another few seconds. As you can see, the remaining altitude is quickly ticking down. And here we go, the burn has started. Now, as you can see, the information here is quite changing quite rapidly. That is fine. It has to calculate a lot of things, so I don't expect it to be 100% accurate. another 10 seconds or so. And there I have killed my actual velocity. As you can see, the readouts right now are quite off from what actually is correct. I will quickly land this and demonstrate that I actually can land on this slope. That was a bit much. There we are. Now as you can see, the deceleration readouts turn off once you land or splash. That is to protect for a division by zero or a null wave. Which basically will ruin all of the engineer readouts. So that's why I made sure they are turned off once you have landed. The second you take off, you will be, again be able to use them. And in fact, you will be able to use them from orbit to decelerate to any given point. On your trajectory. So these are the new readouts. You get your time, you get the point. The point is not 100% accurate, but it is close enough that you can use it to do fairly aggressive burns and save a ton of fuel, literally. And this should help you land even from orbit. So thank you for watching this.